Hello, everyone. This is the sixth workshop of our event. This is our webpage, Megadata and Advanced Technique Demystified. So this is our sixth workshop. We have had many interesting sessions. Today we have Bruno Agard. He works at Polytechnique Montreal. He's full professor in the Department of Mathematics and Engineering at the Polytechnique Montreal. Perhaps would you like to say a few words? Hello, I'm Bruno Agard. I'm the professor of mathematics and industrial engineering at Polytechnique Montreal. So we're starting today with two workshops where we're trying to give a small introduction of metadata, and we're going to use new analysis method and their implications for metadata management in SSH. Today is the first part. We're going to do text treatment, and then on November 10th, we're going to use the same data. We're going to pre-treat data today, and we're going to build supervised and non-supervised preparation environment. Why did we decide to do that? Well, we're going to give perspective data in database to help humanity and social sciences. Data to be analysis are textual data. That is why we're trying today to teach you to treat these sort of data. So basically, we're going to treat textual data. So, Bruno, would you like to add something? Good. So very quickly, I'm going to give you a bit of an overview for today's meeting. So you may have already received by email an email on how to connect to Collad. So we're going to do that together. Then I'm going to take roughly 3 minutes to go through the section 0. And then Professor Agard will take over, and I'm going to do the section 1.2. This will last 50 minutes. Then we're going to present some exercises. You will have 10 minutes of individual work, and then 20 to 30 minutes to do as a team on the 2.2 part. Then we're going to conclude 10 minutes altogether at the very end. So this will be our next 90 minutes. So you have 1.2, and then exercises. Well, some of the things we'll do together, and some others individually. So, how can you get in? How can you get in the file? So first of all, enter this website at the very top, collab.research.google.com. If you have received my email, then you will see the tutorial. I think one of my colleagues also put the tutorial on the cloud or the drive. You can download it. The link is in the Zoom chat box. So you click on GitHub, you write 4.0 dash chair innovation, chair innovation, basically. So it's like CHAIR, like a chair innovation dash Poly MTL. So once you've written this string, you click on the right, then you click on the French or the English, whichever language you prefer. So I'm going to click on the French one. I will remove the Italian. I think it'll be easier for everyone. So now I'm going to see everyone in the room. Perhaps tell me if you're connected. If you're on Zoom, perhaps you could raise your thumb. If you have any problems, let us know. Any issues whatsoever. I see a few thumbs here and there. And everybody else, well, I guess everything's fine. So if you have a problem, just raise your hand. Should be okay. So let's begin the workshop. So today, we're working on Colab. It's a computer platform for Google. And we import a notebook file from Jupyter, and then we can code in Python. Maybe you're a bit familiar with Python. So what's the file? You have some text, natural language text. Then you have code, blocks of code. And then here on the left, you have a little play. And then you can execute the code. So you can then send those codes in the Python. So please click on the little play. It'll run the code. So this is how we'll begin the session. So here, we're going to prepare the work environment. So first of all, your browser must work with Google. This is a virtual machine that is open for you. And then here, the session has been prepared. So then you import and download the modules. Here are the modules you'll need to work with. And then I'm going to take 2-3 minutes, and then I'm going to leave it to my colleague, Bruno. And for those of you, well, actually, is there anyone here who has never wrote a line of code in Python in their life? Please raise your hand. I can see one individual. Another, yeah, some few are not familiar with Python. Well, you're at the right place. No worries. We did this for you. So I think about half the people who are here have never worked with Python. So I cannot guarantee that you will know everything about Python, but the idea here is to at least minimally say, don't be afraid to learn. It is not impossible to learn Python. You don't need a bachelor's degree in computer science. Well, of course, if you have a bachelor's degree in computer science, then you have an advantage. But if you work in humanities and social sciences, well, even you can work with Python. So I'm here to tell you that this is not as difficult as it may seem. So the Python basis, well, in order for you to work today, well, you need some basis. I decided to keep it to the essentials. So variables and function. two things. So variables, essentially, this is an object that contains information. For instance, in this case, I wrote variable with character equals, and then I assign this container. It contains something. So I'm filling it with this string of characters. So if you click play, you just created with me this object. And this has this string of characters. So if you use the print function, this is what you want to print. So it means that you want to print the content that is here. So Python returns the string that you found a bit higher. So this is basically just like a jar that contains something. So it can contain actually a lot of information, and it can contain high variety of elements. It can contain some numbers. It can contain list of characters, numbers, like in this case. So variable with numbers. So you can see below, you can see 5 numbers. It can also contain tabular data. Like in this case, this is a bit more complex. I generated so you have here line 1, and then you have 1, 2, 3, 4, 5, 6 here. This is a variable with a data here, a table rather. So the function, this is a character string. So you have to write a string of characters, and this string contains process. And Python computes it. And the function here does not need an argument. So it can have one, can have many. So for instance, if you want to use the word sum, you want to add or not. So for instance, you want to add the variables in which we have put the list of numbers. So we have here a list with several numbers. So I'm going to do now the sum of all these digits. So I'm writing here this. I'm writing sum, parenthesis, and inside I put the arguments. So the sum is 35. So they can have, you can have here several arguments. Here I have a table. It has data, column, and index, which means I'm generating a table. This is called a data frame here. And it has these data, 1, 2, 3, 4, 5, 6. The columns must be called 1, 2, 3. And you have the rows, row 1, row 2. So you need here function data equal. So what is the argument here? What is what does this argument contains? It has a string, etc. So a function needs some arguments. A variable contains data, and this is the syntax to follow. So you give the variable name equals the whatever that variable contains. So now I'm ready to give the floor to Bruno, and I can see here that there's someone has raised his hand. I want to know if it's a question or not. No, I'm sorry. It's for what we were talking about before. All right. So now I'll give the floor to Bruno. Thank you. Now I'm going to share my screen. All right, all good? Yes. So it'll be easy to see who's doing what because I'm in white, you're in black. So this way we'll make sure that everybody knows where we are. So then now let's continue with what had been explained earlier. So now I'm going to tell you how to prepare text data. This is a bit different. So we'll have to do a pre-treatment. We have to, we'll be able then to do an analysis. So now we'll have to use some tools to change the text in order to put it in particular structure. So now in the code, we have the first part, and in some steps, you need to see the details of the elements that can be found. So in this example here, we're going to start with a sentence, and we're going to use some code in order to extract information. So the algorithms to analyze a text, well, there are a lot more libraries available in English. This is a much easier language to analyze than, let's say, German. So for today's example, we're going to base ourselves on the English, and we also have libraries for other languages because some languages have specificities, and later on we'll give you the French libraries. So we're going now to analyze a sentence. 8 o'clock on Thursday morning, rather, the great Arthur didn't feel very good. So what's written here in the middle, we're going to put it in a variable. This is the first step. So I will click here. As we have seen earlier, now we're going to take this variable. So this we don't know we don't know it's a sentence yet for the programming, just a chain of characters. But now we'll be able to start to work on it. So this is a string of characters. So we're going to take we'll take a look at a number of characters that are in this string. So it's not very useful, but at least we'll be able to provide you an example. But then what we're starting to do now is to put some libraries in order to extract the meaning of this. So numbers, well, that's easy because you can add them, extract them. But two sentences, besides putting them one next to each other, we don't really know what it means. So what we'll do now, we'll take the sentence here, and we're going to take the information from inside the sentence. So in a sentence, we must cut the sentence according to the elements found inside. So you have basic linguistic units. We're going to take all the elements between spaces, and we're going to take a look. Then we're going to remove punctuation. So to do that, there exists in the library an NLTK from Python. I'm going to call the function that is in NLTK, and it's word tokenized, and I'm going to put it into a sentence. So just like Davide has explained earlier, is that I'm putting the function work tokenize from NLTK into the variable sentence. Then I'm adding all of this in the variable words. So what we'll do now is that we're going to take the words and punctuation and going to make a list of variables. We're going to have a list of variables, 5, 6, 7, 8, 9. And here we have a list of variables that will be words, and these are the words in the sentence. And it will separate the words. All good? So now my chain of string is a string of words. So what we can do now here is that all the words in the sentence, well, we can try to see what is their role in the sentence. Are there any nouns, verb, adjectives? So in the Python NLTK library, there's something called post tag, and this will allow classification of words. So I'm going to take all the previous words, and then there are different ways of tagging words, and this will depend on the language. For instance, in French, well, we have here another library in order to do. So we must change the parameters here. So what Python does with the libraries here is to find adjective, adverbs, auxiliaries, conjunctions, and it can do all the classification that we have here. So we have added the list of function to the words that we have here, and here it says that at ADP has been classified. For instance, at is an ADP, 8 is a num, o'clock is a noun. This is done by some library that was already built before. Now I can know all the words in a sentence. Now my string of characters is a chain of words. So if I wanted to analyze the sentence, so now what we can do, for instance, is to remove punctuation. So here, it really depends what you want to do. For instance, some people will work on the style of words. For instance, I want to know, for instance, is there punctuation? Is there an exclamation mark? Or are there three of them? So some people do these kinds of analysis. And then for us, well, we're going to try that. So there are different ways to do this. So here we're going to provide you two examples for the punctuation. And in the first example, we remove all the words if they're not made of letters and words. So there are 12 words removed. So once we remove punctuation, there are 12 words left. And then in the second case, what we have done before to say this is punctuation. So the commas are identified by this string of characters to say, be careful, this character here is actually punctuation. So in here, we have removed the punctuation with this part. So in the two strings of characters, the two ways that we have filtered here, the word o'clock and NT, they don't only have an apostrophe, they disappear in the first filter, but they reappear in the second one. And why do we show you this? Sometimes in the language we want to use. Sometimes we might not have a library to classify all of this. So we have to develop ourselves our little code. And we have to say, well, if it's not alphanumerical, then I have to remove the information. Here I have some text that has been enriched by the tag on the second part. This is an adjective, a noun, a pronoun. I'm using the information. So now we have two versions. We could keep the filter text with the first method, or the example here, I have kept the text filtered by the second method. Something else that we can have here in the text is that depending on the position of the word in the sentence, is it in the beginning? Is it in the middle? Well, here I have a little code line. And for instance, I can now remove capital letters. So for Python, all of this can be two different strings. One has capital letters, the other doesn't. So these are things that you have to be careful. So when we went to smaller letters here, we have here UNESCO, USA, UNESCO, doctor. So if you remove their capital letters, then they have no meaning. So you can now you have to combine the two methods that we had earlier, only for things that are not proper nouns. So I'm using the previous tag to identify word, verb, everything. And I'm saying if you're not in the category proper noun, so now there are now some, and you have USA, UNESCO, UN. So if you're not in this here, then Mr., Miss, everything, then you can keep the capital letters.
Donc on enlève les espaces, on enlève la ponctuation.
We take out the spaces, we take out the punctuation, and we process the capitalized words as I've just explained. But we have a number of other words to analyze in this simple sentence, articles and other more complex things. What we're going to do in some languages, particularly in English, but also it can be done in French, we can remove the words that don't have meaning. In French, there are a lot of them, such as je, tu, il. In Spanish, you don't even use the personal pronouns. So they can be taken out. In some languages, there are meaningless words, and there are some in English as well. They're referred to as stop words. And in each language, they can be, you can access the stop word library for the language in question. In NLTK, we import the stop words and they say, okay, we're going to use the English ones. And here, we're going to display some of the words that don't have a lot of meaning in English. And if they don't contain much meaning in the list of the words that we had before, if the word is not there, I keep it, and if it's not on the list, I drop it. So previously I had a list with 14 words. I filter, and now 9 words are remaining. These are words that have meaning in the sentence. Okay? Again, this should be done parsimoniously depending on what you're studying. If you're doing poetry or a song, the meaningless words, the stop words, have a role in terms of rhythm and so on and so forth, and they need to be kept. But in this case, they don't, so we remove them. Is that okay? I'm moving forward at the right pace? Good. I had a question in English. My question is, in English, often there are prepositions that accompany the word, that change the meaning of the verb. How do you process that? Might they be caught up in stop words? By or something of that sort? Just raising it as a question. No, that's relevant. By default, we would take them out. We could do this by treating the words not by individually, but by groups of two. Go up and go down. There's a big difference there. But we're taking them one by one for the time being. But it is possible to do it otherwise. Because, of course, there is meaning there and we might lose it. But we've simplified things to the extreme here for the purposes of our exercise. So another level, and this is applied to the English again, to increase the frequency of the words, we look at the number of occurrences. We had 14 words initially. We took out the punctuation, and then we filtered again, and we had 9. So we might have a text that says the cat or cat, but the concept is the same. It's cat, singular or plural. So in our classification, if I want to look for things that are frequent, I might have 3 or 4 different variations. So the idea is to do stemming, that is to reduce them to their stem. And there are tools to do that that depend on the language. So you have to be careful when you choose the library. For English, we have Porter Stemmer. In some cases, people aren't entirely agreement. There are various ways of reducing them to their stem. But this is for people who are really specialized, where the type of stem can be important. But I'm going to show the results for 3. I'm going to apply Porter's method, Lancaster's stemming method, and the thesaurus-based method. And you can see that there's a slightly different result here. Great is reduced to the root, the radical. So we go from original to less original. And we will reduce the number of different words. And I can, so with the Lancaster method, we can put them together. Perhaps I don't want that level of resolution for the type of analysis I'm going to be doing. Yes, when you're working with the French text, which would be the most appropriate? Well, we'll look at the libraries for French later. We wouldn't use these. because it is language specific, but you have to be careful to apply the right library. In French, there are plenty of quite workable libraries. Also for Italian, Spanish, and so on. So the Latin languages have been pretty well covered. This is inaudible. It's not being picked up by the mic in the classroom. The verb? In my list of text, there are abstracts for various languages, French, English, Spanish, Italian. So usually we only keep what's in English, but in the abstracts, there are abstracts in French, which might be useful as well, but a minority. In those cases, if you want to work with several languages at the same time, it's difficult to call up more than one library at the same time. Well, we would separate our processing English, French, Spanish, and the method would be the same, but you're using different libraries. So you prepare your environment differently. Even at the end, to reconstitute everything at the end, it's difficult when there are different languages. Yes. Because, well, it's not only because of the translation. There's an example which is not here, but bâtiment, for instance, French. It could be a bâtiment, could be a building, or it could be a warship, for instance. A dictionary of synonyms would be required to make the choice. You have to put the sentence in its context in order to be able to process the words with what's preceding and what's following. But in what we've prepared with Davide, of course, we've simplified again. Let's not get too far ahead of ourselves. But we're not going to have any induction on the basis of the position of the word in the sentence. There's some manual work that has to be done, even if we have very extensive libraries. Inaudible? Well, that's a good question. There are some things that have to be done by hand. You do have to add dictionaries. In my context, these words are synonymous, and some words are synonymous and others aren't. So in the list of the words that I would remove, I would already have looked at what can be taken out. But I might keep some in particular contexts out. And in some cases, add. I might have a second list. Sometimes when you're working with stems, when I say minou ou chat, one is a kitty cat and the other is a cat. Basically, it's the same. But there can be cases where the root is not the same, the stem is not the same, but they are synonyms. So synonym libraries or dictionaries can be used. And the question is, what is the sense in which they're used? The distance between the words. But this is beyond our purview for today. So we lemmed the words, or lemmatized, and I have a smaller number of words now. I've got an odd sound on my end. I'm not sure if it's a problem. So I recovered the words, we filtered them, we boiled them down to their stems. At each stage, or these different steps may not be necessary for all texts. Sometimes you want to stem, and other cases not. You'll use the tools based on what you want to do. There are some examples, and we'll look at this now, is we're capable of, we can identify each word as a noun, an adjective, and so on and so forth. Maybe we want to filter, which is done here in this code. Maybe we just want to look at nouns and adjectives. So we look at the list, and I just want to look at the concepts of noun and adjective, and everything else would be removed. If I want to look at the actions around the nouns, then I would look at the verbs, and so on and so forth. But you can discriminate. So I've got my text. I have a chain of characters, and we they can be words, they can be digits, and so on and so forth. And on the basis of their identification, they can be filtered, they can be stemmed. I can put them in lowercase or uppercase. All of the words can be stemmed to the adjective, to the infinitive as well. And we've looked at what we could do in terms of removing the meaningless words. If I say I eat the cat or the cat eats me, it's not the same meaning, obviously.
Oui, non, puis je suis d'accord.
Yes, and the position of a comma, for instance, in the sentence can change the entire meaning. Right. So we've looked at how to do a processing of a single word. Usually, it's not limited to a single word. But in terms of the automatic tools that we have at our disposal, we can look at huge text. But let's take one that just have 3 sentences. We'd separate them out. Now we can look at the 3 sentences and do vectors sentence by sentences. We could do the same thing for a paragraph and for an entire book. I can sort the chapters in sentences or in a chapter. Maybe you want to do analysis by paragraph, or you might want to generate a list of words in a chapter. Again, it all depends on your purpose. You might want to know, are we going to use the imperfect, or is the text using the imperfect more than the present tense, or so on and so forth. So you can also specify the tense of the words. So here's a sentence I put in a variable. The first, whoops, sorry, I forgot to execute the code that places this sentence in the variable, the text variable, which is just a chain of characters, which contains 175 characters at this point. We used the word tokenizer library that took all of the words out of the text. Here, what we're doing is I'm breaking the sentences down. Here I have a sentence, a comma, a second comma, a comma, and could say I start with a point. It might be an exclamation point or question mark, depending on the language, and so on and so forth. And we'll have a table that will have the first sentence, second sentence, third sentence. Then what we can do is, in each of these sentences, we can apply the very steps we looked at earlier. To avoid too much repetition in Python, we can define functions. We executed functions, led, we separated the words while taking out spaces and so on and so forth to create a library. So here, for instance, Davide created this function, cleaning text. And it applies some of the things that we saw earlier. For my analysis, I might be interested in a particular stem. Once I define my function, I can apply it, which is what is done here. I have a function. When I execute the code, cleaning text, it does all of this. It recovers the word, identifies them as complements, subjects, etc., etc. It puts the uppercase and lowercase and so on and so forth. All the things that we looked at earlier. And depending on the parameters in the function, we can apply a particular stem or not. And you can define the language you're working on, and use the cleaning function. So the function is cleaning text. I'm applying it to the sentence, and I put it into the variable as cleaned. So the sentence has been broken down. Punctuation has been removed. Uppercase has been removed. Things have been reduced to their stems. And we've identified the parts of speech, noun, verb, etc. So these are 3 sentences, but we could apply the same function to a very long text, and it's just a matter of sentence, which is what we're going to look at. If I've got a lot of words in a lot of sentences, I might want to count for each text how many times a given word. So here we see that we could do a calculation. Freckdist shows us that morning appears twice, Arthur twice, Thursday only once, etc., etc. Is that okay? So we're counting the number of words in the text, and we can do word frequency analyses. And so on. Now we can take this a little further. We know now how many words there are. So we want to tabulate this in a matrix. So I would have columns with the words as they exist somewhere. And I would have x1, 1. So I want to know if 1 appears in text 1. I give a line. It could be a paragraph. It could be a chapter. It could be articles, depending on what we generated as a list of words in the text. So I could have a text, chapter, books, and so on and so forth. I could have a vocabulary of the corpus, and we would say, oh, we could look at where does the word in column 1 appear in text number 1, etc., etc. So that's vectorizing. There are various ways of doing it, and we'll look at this a bit later. We'll see different vectorization methods. And next week we'll look at how this is done with different predictions. But we might say, I'm going to use, I can use the vocabulary or not. If we know that the word is there, in the, at least once in the text, it would be 101010. But then we count the frequency, the number of occurrences of a word in each of the text. And again, we might reduce this to a percentage. If we have 10 lines or a page, we'll get a different result, obviously. There's also a representation of the number of words in the text compared to all of the words in all of the text. The word TF and IDTF. The first is the word frequent in the text I'm studying? And the more frequent it is in the text I'm looking at, obviously its relevance increases. The second thing, the log of the text frequency looks at all of the texts and sees its frequency. If it's present in all of the texts, then the inference is that it's not that significant because it's used in my text, but it's also used in a lot of other texts. So you can measure the relative importance of a word in a text compared to a large number of texts. So there's no ideal metric. Everything will depend on your objectives. Are you going to classify or what? I might want to group words, but this is very useful when I want to do classification. Again, it's a question of what you are planning to do. And again, to do this, there are a variety of different libraries. Whoops, sorry. Davide, is it up to me to do this, or is this your part? Well, maybe we could wrap up on vectorization first. Okay. We have vectorization is transforming this text. We're going to do a vector for each of element of the corpus. It could be a sentence, a paragraph. We can define it as we wish. Since everybody has the same needs, let's suppose here in an LTK, there's a function that enables you to take a given corpus and extract the words and create the matrix that we were looking at a moment ago. You have to be careful here. If I apply the count vectorizer method on the initial sentence, perhaps I won't have processed the grammar in the appropriate fashion. The cat or the cats, cat with or not without S, might be in two different columns. Why? Because we would do the preparation steps, and then we would put it through the vectorizer to create a matrix of the words that we'd already grouped together. Okay, so here we have the vocabulary of the various texts using the clean sentence method we looked at. Then, okay, I forgot to launch that. Okay, count frequency of the different words to create the matrix. Does the word appear? I have a matrix with the 3 sentences. In the first text, you can see Arthur, dog, feel, good, great, morning appeared. In the second, Arthur, felt, following, morning. So we reduce the words to their stems, and then we put them together. You just have to apply the stemming. And careful with Python, numbering starts with 0. 0 is the first text, 1 is the second text. Okay, here we just have the, is the word in the text? Yes, no, yes, no, yes, no. Here, the second stage, which TF-IDF, you see the number of times the words compared to the other text. And you can calculate the significance of the word relative to all of the texts. You can also weight the words. Are they more weighted with respect to adjectives? Who is acting? And so on and so forth. I don't know if there are any questions at this point here in the room or online. Okay, Davide, over to you. Okay, I'm not seeing any questions online for the time being. Hang on, I've got a question here. To hear the question, the person's going to have to turn on their mic. Yeah, we tried to do that and it didn't work. Okay, I can hear you, but other people probably can't. Inaudible. Inaudible for the interpreter. Inaudible for the interpreter. Okay.
Alors, la question que j'ai dans la salle, je vous le répète parce que j'ai l'impression que les
So the question in the room, I feel that the microphone is not working. Can we do some treatment? Can we give prior weight to the word depending on what we want to do? We can do it before, after. Here we have normalized things. And if we weight something, it is as if we're doing a much bigger weight, and it gives a much bigger weight then, depending on what you want to do. Personally, I want to do it before. So if I decide that I have proper nouns or proper nouns, and then it'll be part of the frequency and all of this. And if we go through the log 10 times exponential 10 when we can transform it. So yes, I've been playing with much smaller figures. Thank you. I think that the microphone was not on. Oh, can I? Yes, I think that I can continue now. Excellent. So I'm going to start part 2. It'll be quite quick, and then you will work individually. We're going to divide all this in different rooms. So we're going to have some. We're going to divide you in rooms automatically. For those of you that it's the first time that you're coding, if it's the first time you see these kinds of work, well, there have been some questions. Some questions are more advanced, of course, especially for those of you who have seen this for the first time. So it's very normal if some things may not seem as clear. So I just wanted to make sure that you understand that Bruno has said basically that you take some text, we have to transform it, you put it in a matrix, then you'll be able to analyze it with algorithms. This pre-treatment, as you've seen, the main thing here, you have to reduce words in a unique form. For instance, in order to concentrate as much as possible the frequency of a word. Then there has to be an analysis, and then you can take the semantic of the text, because if we keep all the plurals, if we don't do this pre-treatment to reduce the number of words to keep it to the basics, you risk to lose into the analysis the information that you're looking for. So the goal of the pre-treatment is to reduce semantics so that the computer know which form to treat. So that's the main goal. So of course, if we are in basic methods, there are more advanced ways where you will need to do some pre-treatment, but this is a context, this is a usual context of social science, and this is how we should get there. So let me start with the exercise. So what are we going to do here? We're going to an analysis of feelings. Sentiment analysis should be the right way to say it. So we're basically doing a treatment of natural language. We have to take some text, and we have to see if the text is positive or negative. The simplest one to understand is the one widely used in the industry is, for instance, take comments on a product. Imagine I'm a seller on Amazon, and I have some people who make comments on a product, and I want to know what are the feelings behind these comments. Are there any comments? The comments behind my product are positive, negative, or imagine I'm a political party. Imagine that I'm doing the analysis of communications of my political party, and political members are active on social networks, and I want to know who are the members of my own political party that have positive or negative feelings. So these are the examples, and today we're going to do an analysis of feelings on Twitter. This has been fed by trackmyhashtag.com, 150,000 tweets for 50 profiles. For instance, we have Messi, who follows soccer. We have the BBC. We have about 50 profiles. And then we're going to take a sample of 5,000 tweets, and we're going to do a feeling analysis from them. So in a few seconds, I will come back. I'm going to explain what Bruno has said, but for now, let's just take the data. Let's import the data. So I'm going to give you a sample here. And then we're going to do the pre-treatment as Bruno has explained. So I'm going to take some concepts here. I'm going to do some redundancy, and then I will explain what we want to do. And then we want to work individually and then by team. So we should finish everything around 1:45, 1:50. 2.1. Let's begin by importing data. We have to click on a button. We generate a contain called df. In df here, this is a table. df, why? Because it's a data frame. So we're using a Panelists library on Python, and df has columns. These are the columns. These are the variables that we should find in. So I have an index, tweet ID, tweet URL, etc., etc. So now we're going to use some of these variables. Specifically, we're going to use the number of retweets. We're going to use, where is it? Username. And we're going to use text. Tweet content. So let me give you an example. This is the first line of our board. This is the first line here, and it has its 50 columns. All of these columns that have these values. This is the username. The profile account is Justin Bieber. It's a profile made by Justin Bieber. And the content is this one here. So we here we see the at Justin Bieber or hashtags. So this is an example. So we have here the number of retweets. We have the number of likes received. And there were 20,000 retweets. So here we click on play. We generate a variable, and it contains the algorithm sentiment intensity analyzer. SIA has all the algorithm. Imagine now that you have this sentence. In English, wow, Montreal Canadiens is the greatest hockey team in the world. And then we're trying to see what are the feelings behind this. So I'm going to show you the result. So we'll see in this variable, we have polarity score. So we click here, and then we have, so this variable here, it has no negative feelings, 0.52 of neutral feelings. So the scores are between 0 to 1. Then you have 0.48 for positive, and the matrix gives 0.8516. So this allows us to see the feeling of the sentence is very positive because it's the compound goes from -1 to 1. So we have here, Ottawa is not a bad city. We have 0.56 neutral, 44 positive, but a compound of 0.484. It's not that positive, but it's not that negative either. But if we have here, no, you cannot put pineapple on a pizza. It's disgusting. That's so true. Now we'll click here. It seems to be to take a long time. I think even Python is disgusted by pineapple on a pizza. I'm just joking here. Oh, I maybe have an internet connection. I think I may have a problem on my side. Well, I cannot keep talking, but this is not normal. All right, with the screen share, I'm going to take over. We keep spinning.
Qu'est-ce que nous avons? Bon, là, vous voyez qu'il est compound.
Now we have here minus 0.73. So we're giving here a sentence. We're coming back before. So we have here a score that is either positive or negative. So when we have the block code of number 43, we have a list, as Bruno has said, a list. I have here, all right, I think it's Bruno, I'll take over. Sorry, if I can, if it works. Sorry, thank you very much, Bruno. So here we have an example of tweet content. So we're going to work on these sentences, on these tweets. So essentially, this is quite simple. I'm going to apply this on all the corpus that we have imported earlier. So I've put it over the whole text, over all these tweets. With this, I've used this function. So here's an example. So you have here the tweets that we couldn't really see well earlier. So in feelings, it goes to when we minus 0.128. So I'm going to show you these tweets. What is the content of these tweets? So content of the tweets, it's a link. Justin Bieber said something, and then he put a link. So that's the only content. How can I say? It's very small as the text. Some have more. Some are not in English. Most of them are in English. We have another one. So the compound here. So only to give you an example. So we're going to work on the compounds. The maximum value is 0.98. The minimal is minus 0.97. And 25% of our tweets, 75% rather, have more than 0.55. after the distribution. And then we're going to see here this block of code, and then we're going to count the negative are 630, neutral are 2969, and the positive are 1401. So what does it mean? It means that under the basis of a cut that has been done here, we have 1,401 tweets that are positive, 630 are negative. So I know I didn't really explain well. I was a bit confused because of my screen share. But this will be the code that we find ourselves as mode. So I've cut this distribution. So I've cut this in categories. The negative category, the neutral one, and the positive. In the negative, I've put everything that goes to from -1 to -0.01, and everything that is in the category neutral is from -0.01 to 0.05, 0.5 rather, and then I have 0.5 to 1. So in order to have this result. So I'm going to come back here for the last 2 minutes. What do we do here? We're going to take the function that Bruno explained earlier. Here, I'm going to clean the tweet. We're going to do the pre-treatment. So in this line of code, you have to take a look at this argument, because this is the argument on which you work. This is the argument on which you must define what are the post tags. In other words, the analysis of the morphosyntaxis, the component of the sentence that you want to remember. So in this case, I've only took the adjectives. I could also add, say, nouns. Let's just do that. So you will do now this exercise. So you have to keep in mind what are the words that you want to keep in the list. I must work only in the adjective because it will take a few seconds. And of course, after that, we're going to have to click on the other ones. So we click on this one to start the vector, and then we determine the matrix, 5,000 tweets for 172 adjectives. All right. This is a function to do an analysis. So I thought that we could have it here, but we don't have it. So, but essentially, we keep lexical specificities of the categories that we give. So you will see here in the next example, it'll be a bit more simple. So I take the compound category, the category that I've generated earlier. I have it here a bit higher. We have the compound category. We have the negative category, neutral, and positive, with the different splitting that I've mentioned earlier. So I have a variable. It contains the nominal value, negative, neutral, or positive. And I'm going down. So here, I want to generate an object that I need, a logical object, logical vector. So what we have to see is that I'm going to analyze the category called positive. I could analyze the neutral or negative, because compound category contains these three values. So I'm going now to analyze all the tweets that have a positive feeling. There are 1,401 of them. So here I have a function to get lexical specificities. You need two arguments, the matrix of frequency and also this logical vector that you have here with the syntax. So I'm click, I can see the result. So what is the result? So in the adjectives that are found in the tweets that have a positive feeling, these are the most specific ones. Adjectives that are found in the tweets. So, well, we're not surprised, but most of them are seem quite positive here. So this is just to show you the code here works. So you can now have fun with other things. So what I'm suggesting now, well, you're going to be in a team. You're going to take 10 minutes, not even, because it's 1:22. So you're going to read in 5 minutes. You're going to read 2.2, and then you'll try 15 minutes to work as a team to fill the part of the code that are empty. So we have blocks of code with 3 dots. So you have to fill the 3 dots. So now here, the example is exactly what I've said earlier. So there's a least pos to keep, and then you have to add the post tag to keep it for an analysis. So earlier only took the adjectives, and now you can choose a noun, a verb, and then you have to put in the post tag. We don't have much time. So now let me put you as a team, and I'm going to go around in the different Zoom rooms, and Bruno will remain in the main room.
Doucement, tout le monde revient en salle.
So slowly but surely, people will be filtering back. And this is just basically to bid farewell. I repeat just basically what I said in separate groups a moment ago. Look at the file over the weekend. Look, all of the fundamental concepts are in the text. And the exercise is basically cut and paste because it contains code segments that we've already explained. If there are any questions, write me an email. I'd be delighted to help you out. And if you want to learn more about what to do and not to do, that's great. Thank you for being here. There was a little bit more material than I anticipated, and it took a little longer, but we'll see each other again in 2 weeks with the next session. Again, we'll be using a notebook file as today. So we're going to do Python again, and we'll take what we learned today a little bit further. Does anybody have a question to fill the last seconds or minutes? while we still have time? Well, if not, thank you to the interpreters as well, and have a great day. Thank you, Davide, and we'll see each other in 2 weeks. Great, see you then.